Okie dokie. Let's see how this works. Continuing on with finding the inverse functions. Now, like I said, having that wonderful little unit circle comes in extremely handy for this stuff. So if I want to find the exact value of the inverse tangent of 1/2 and then the sine of that, what is that going to be? Well, when we're dealing with tangent, that's a little bit trickier, simply because we got to think of it in terms of sine and cosine at times. So here, there's one way to take a look at this, okay? If I want to go through and find the exact value of what this is going to be, okay? So that means that there's some theta out there where tangent is going to be equal to 1/2, okay? And it's from here to here. So what would that end up having to be? Well, let's see here. When we're dealing with this, we'll think about it in terms of a circle. So tangent is equal to what over what again? Sine over cosine. Which one's x, which one's y? Y is sine, x is cosine. Okay. So this means up here that the tangent of some theta is going to be equal to 1/2. That means x is going to be 2. So this is 2. This is going to be 1, correct? So from this information, we can go and figure out exactly what this is going to be. Well, 2 squared is 4, 1 squared is 1, so this would have to be the square root of 5. Okay? So tangent is equal to this. Okay? Now, some theta gave us this information, and now I want the sine of how that goes back. So this is kind of doing a lot of back and forth on this stuff. Okay? So when we look at this now, they identify your theta is in here. We've got our point. We've got our distance there. So this is theta. So that means the sine of some theta. What is it supposed to be equal to? Well, what would be the sine of this triangle? Sine is what? Opposite over hypotenuse. So that means that it's going to be 1 over square root 5. Which also means that we can't leave it like that, so it's going to be square root of 5 on top, square root of 5 on the bottom. So that means that theta is going to be equal to the square root of 5 over 5. So dealing with the triangle, dealing with the inverse is what's necessary to think about in terms of, circle down here. Now, we try as often as we can to set these things up in the first quadrant, because sine and cosine both apply there when we're looking at the inverse. Does that sort of kind of make sense? So let's try another one of these. So I want to find the exact value of this. Now, I've got that negative in there. That negative is going to cause us a wee bit of a problem, isn't it? Let's go back and think about what it is that we've got. That means the sine of some theta has to be equal to negative 1/3. Where is sine negative? Well, if we go and take a look at this, we say that sine is on the, let's say this whole page here. Sine is the y. Where is y negative? Y negative is down here. So we're looking at a theta that's going to be down in this neck of the woods, right? So let's draw the triangle in those terms for us. So circle. So what we're looking at is something going down here. And now mind you, this is where our theta is going to be at. It's going to have to be negative. So sine is equal to that. Sine is what again? X or Y. Y. So if I am trying to identify that coordinate down there, what would it turn out to be? Well, as we take a look at this, this turns out to be negative 1 and 3. Why? Because sine is equal to opposite over hypotenuse. So if our opposite has to be over here, opposite over hypotenuse, we've got that as 3. This is going to be negative 1. Do I know what this value up here is going to be now? Well, 3 squared is 9. 1 squared, or negative 1 squared is 1. So if we're looking at this in terms of x squared plus y squared is equal to h squared, we end up with 9. Oops, sorry. 1 plus is equal to 9. So that means that I've got 8 over here, correct? Which means that it's going to be 2 square root 2. Correct? So I know that this distance here is 2 square root 2. So the inverse of this brings us to some theta. Okay? Now that theta is what we have to put in here. And cosine is equal to adjacent over hypotenuse, correct? So what's the adjacent side to the theta? 2 square root 2. What's the hypotenuse? 3. So 2 square root 2 over 3 is what we should end up with. And that's exactly what we got. Okay. Now, is it going to be positive? Is it going to be negative? Got to be positive. Why? Where does it sit? It sits right there. A lot of mental gymnastics in this thing, isn't there? So let's try it out. Let's find the exact value of that. Okay, so cosine. So what we're looking at is that there is some cosine of theta is equal to negative 1 over 3. Okay? and this is adjacent, and that is the hypotenuse, correct? Now, where is cosine going to be negative? Because cosine is x. The only place cosine can be negative is sitting over here. Yes? Now, this triangle is going to look a little on the different side. Because, whoops, sorry. Because what we end up with is something over here. But now, how is this going to play out? When this works out, we're still having to have this deal on a right triangle, correct? That means that I have to think about it over here in these terms. I can't think about theta going this way. I have to think about theta being right in here. So we'll have to deal with that a little bit later. But this theta is the only thing that I can deal with right now. So that turns out to be negative 1 over 3. Adjacent. So this is negative 1 here. This is 3 up over here. So again, we got our x squared plus y squared is equal to hypotenuse squared. So that's 9. That's 1. So again, this is going to be 2 square root 2. Correct? So now, that means that whatever it is, that theta produces this triangle. So that means the tangent of theta is going to be equal to opposite over adjacent. So that'll be square root, it'll be 2 square root 2 over negative 1. So this should be negative 2 square root 2. Let's see how close we got. But it says it's, we get that going down there. Whoops, sorry, I got to continue. So we end up with negative 2 square root 2. Because it's dealing with that right triangle, we don't necessarily have to worry so much about what the theta is. We just need to know that the theta puts us in a certain spot. Does that make sense to you? Then set up the right triangle. So here they've got the definitions for your inverse secant, inverse cosecant, inverse of cotangent. So let's play with this one. Find the exact value of the inverse of the cosecant. So I've got that sitting there. Cosecant is the same as what? Okay. And he said cosecant goes with sine, right? But it goes like this, right? So what does that mean? What does sine have to be then? Because this is 2 over 1. What would sine have to be in order for that to be that? What would the sine, what is the sine of theta equal to in order for that to happen? Okay, so it's equal to half. Well, think about it. This is 1 over sine of theta. So it's going to be the reciprocal to get back to it again, because you don't divide by a fraction, multiply by its reciprocal. So now we're at that. Okay, and this is opposite, right? Over, oops, Opposite over hypotenuse, correct? Now, we're supposed to find the exact value of this thing. Where does sine of theta equal half? Well, we'll go back to here. Sine is the y here at half. Okay. And since we're looking at going from the inverse, it only exists over here, so that means that the theta here is going to be pi over 6. So we should be looking at pi over 6. Let's check. So go through all that stuff. Because it only comes from negative pi over 2 to pi over 2, that's the only place we can look for it. So we end up with a pi over 6. Now, we've talked about this before. Calculator doesn't have those keys. We just have to, use it in the terms of 1 over that. I'm not going to go over that because that's just a calculator exercise, button pushing. Okay. All right. So, moving this along and writing things out as an algebraic expression does take a little bit to get the hang of. So let's try this. I want to write that as an algebraic expression containing u. So we're going to start back with the same way we did before. So I got tangent inverse of u, which means that the tangent of theta is equal to u. Is this correct? Now, tangent is sine over cosine. So that means sine theta is going to be equal to u over 1. So, triangle. Here's our theta. So, cosine is equal to what over what? Opposite over hypotenuse. This is adjacent over hypotenuse. So in order for this to work out, what does the hypotenuse have to be? 1, right? Sine would have to be u, and cosine would have to be 1. Does that track in your heads? Okay. So we've got that. Now we're going to write the sine equal to this, right? Containing u. Now let's see where we're at. Oh, that's right. That took care of that. So now I got to take the sine multiplied by whatever that was, right? Okay, so this is where we were at. And we were supposed to write this as an algebraic expression, right? Sorry, I got kind of, let's see, how do I want to say that? Distracted. So, does this help us out? Does it help us out? So if I want to know what's going on here, I'm supposed to write that as an expression containing u. We figured out what all those bits and pieces are going to be. Did I do that right? And the more I'm looking at this thing, I think I've taken it down. And the reason I say that is because when I'm looking at this stuff, I think I did. I think I have one on the wrong road with that one. My bad. Terrible, aren't I? What was that? I hear muttering underneath the breath, somebody's breath. Jake, Austin, you're still causing a distraction. Let's try this again. So when we're writing this as an algebraic expression, we're not necessarily trying to go through and solve it. We're just trying to rewrite this thing. Now, some way, shape, or form, we know that we have to come up with inverse tangent of u. So, let's see, what was that?